Hey, welcome back. I'm just checking our live stream. It seems like we have excellent connection, so I'm just waiting to see. Sounds like we have some sound and video seems okay. Cool. All right, so jumping into homework 1. Thanks so much for all of the hard work that you put into like the readings and connecting things. I wanted to go through some of the things that I noticed that maybe you could use like further explanation or even just like thinking about how to do this stuff. And then I noticed like some ways that people were doing things that might have been like inspired by AI interactions. So we'll try taking some of the problems, putting them into ChatGPT, and see how we can work with the output and how do we take that output and make it our own and think about it that way. Oh, and I had already done this stuff. I think this was in the last video we were working on. I didn't notice anybody have too much trouble here. The one thing that it's always a little weird and open-ended, which engineers in general don't really care for, but in this last question, like how do I get B to be true? This is really common when you're dealing with like string. You end up dealing with strings a lot, like in data sets. And sometimes it's kind of weird, like the name Ryan should equal the name Ryan, whether it's capital, lowercase, and all of this. But what you already found when you did this work is that string 1 is not string 2, that's a false statement. So we can force things, we could make both of them lowercase like this, and now it is a true statement. I saw one thing of like string 1 equals string 2, and then does string 1 equal string 2? Why, yes it does, but that overwrites it. So maybe that is what you want to do. Is like you already knew that string 1 and string 2 should be the same, but now if I try to rerun any code of like is string 1 less than string 2, it's going to tell me that it's false, even though it might have been true before. And it's kind of strange that things are less than or more than, but capital letters are a smaller number in that IEEE, like because it's a string, and strings are just represented in the computer as like bits, and bits are always numbers. So A is less than lowercase a. All the lowercase letters are less than. So even like capital Z is less than lowercase a. So again, if you want to make sure, one way to do it is like dot lower or dot upper, like force everything into one or the other. Or you can use other things along that way. But strings can be a little weird as you're playing around with them. So just make sure. You can add strings, but you cannot subtract them. So Python, but I can't say this. I can't like take that away. I can't use that. I think I could say remove dot, is it pop? No. Subtract a value from a string. Dot replace. So dot replace would work. And maybe that is the best way. Dot sub is okay. Oh, and there's all these different versions too. I guess I said I was going to open up ChatGPT, so we might as well, right? So pop this in. So I'm going to give it this information and then also give it this information And let's see what it tells us to do. And so now I could take this, kind of copy it over, and let's so both of these are true statements, whether I turn them all into upper or lower. And if I was going to use this code from ChatGPT, I would probably like at least like label it here, because the goal is always whenever you find like code from another location, you should always copy, paste, and improve. And at least now, and so some tricks that I used here, at least like getting ChatGPT to give me the output that I wanted. This is all, whenever you give code to ChatGPT, if you can get the markdown or the LaTeX or any kind of like raw format, closer to raw format. We don't have access to like the bits inside the computer, but we can get like here, all the code is marked off with little tick marks to make it look like code. It's even giving some hints here to say like, hey, you could use string lower, string upper. So we're doing some prompt engineering just by doing that, rather than like trying to copy in this raw text where it's readable for a human. But for a computer, this is a lot more readable. So you're gonna get better results if you're using the actual like Markdown or HTML code, like if you want to use HTML for that. And then, yeah, if this was me, I would also like down here put, I would write in modified code from ChatGPT analysis, or I don't know, conversation. I don't know what we using problem as prompt for initial results, something like that, where I'm saying like, hey, it's code that I'm using and it seems to work. I understand what I'm using, but I did start off like ChatGPT was the generator for this. Anyway, then yeah, so this was the other one that I thought might be kind of interesting to put into ChatGPT. So let's do that. Let's copy this code in here, because I think I saw some other people using things. Yeah, okay. So this was a similar thing to what I had seen in the in some of the output. And again, like you can definitely use ChatGPT. It accelerates a lot of your problem solving, and it's probably going to help you think about these problems in a different way, or maybe help you think about them like even if you're just hitting a wall. So it's a great way to like clear that blank canvas and give you something to edit. But if you're using it, make sure that you have some kind of like either a note saying, hey, some of this code was generated by ChatGPT, or yeah, just give me a heads up, because it's a lot easier to help understand where the code's coming from and how to troubleshoot it if I know that is AI generated and not human generated, because AI makes some weird choices here and there. All right, so let's see. What is this thing doing, and how is it working? And it does seem to give us what we want, right? Like zero is always going to be, like, all these things are going to equal 0 because 0% anything is always 0. And then as we move on from there, let's go up to like 2 times 3 times 5, so we can look at, and then we want to say +1, just so we can look at up to 30. So compmec rocks and compmec rocks, and then all of our like 7, 13, and 17, they're all giving us what we want. So one thing, if you played around with these if statements, so there's 4 if statements in here and no else statement. Like, why? So one thing that you might think is like, hey, if these 3 things are not true, shouldn't I just be able to say, let's comment, or do that, comment that, and say else. Because it should be that if this is false, that's false, and this is false, then do this, right? But if I do that, I end up with this thing that anytime it's not 5, so anytime it's not divisible by 5, the output is that integer. So taking input I and turning it into a string, and then appending it to those results. And that seems a little weird, but the reason for that is that really, if I want to use this else statement, I would need to include it in all of these, because each if statement is starting a whole new if block. It's not looking for a single else. It's looking for an else statement in each of those blocks. And there, we're starting to get a little bit better, but again, because the last thing that it does is check this and then turn the output into that string of I, it's not actually doing what we wanted it to. So that else statement is not really doing, that's why we're saying like, hey, if this output is still nothing by time we get to, so it hasn't added this, it hasn't added that, it hasn't added this, so it's still just a blank what we started with. Now we'll append the integer I as a string. And here, let's see what happens if we regenerate. Oh, can I just say, just try again. So I want to come in here. I just want to come in here, use if else statements to create the output. And here it's still not using if and else. If, elif, and else statements. So let's send that over. Let it generate this. Here, this is what I was looking for. Is that another option is going through the if, elif, and in this case, it's looking at the most general case first, and then dropping into the least general approaches. And the reason for that, and we can double check, make sure that it works. Let's do that. And it seems to work. For some, and again, for some reason it replaced these colons with this index, that like thing there, but let's put the colons back. I kind of like that one. I like the format. So the reason that it has to use this is that every time you hit a true statement, all the values below that true statement get ignored. So I can't start with, I couldn't put this one up at the top. Like if I try changing the order of these, so everything is exactly the same, but the only difference is I put that %5 before this check and before that check. So now when I get down to like like this mechanics rocks, we should only see rocks, I'm pretty sure. Let's see. Yeah, so there, rocks, because even though it's divisible by both 2 and 5. And so elif, the way that elif works is a little different than just plugging in if statements and checking each one. But there is an else statement that covers all of those if and elif commands. So I can use else because this elif is part of that if kind of checking thing. And both of them work. And if they get the job done, then, I mean, they get the job done, right? It's not that. I wonder if we could say, let's try changing one more thing. Use a numpy array to do Boolean operations. I don't know what this will give me, but if I wanted to force it to use numpy, so it's going to create, so number, it's going to create those numbers, then add those. I don't know if this will work. So we'll try it just one more, just to cover all our bases, and then we'll see. So it does work. Oh, so it's still looping through each of the numbers anyway, though, and still using those if statements. I thought we could do something else. No, not really what I was looking for. Anyway, but a little bit of ChatGPT, a little bit of like modern day programming. Like we have this tool that has collected all these different libraries and people's work and all sorts of resources and kind of condensed it down into one pretty easy to use like robot chat that we can plug and play with. Okay, so then this was the other one. The one thing that I noticed here is that a lot of people, when they define this sine cosine of x function, they skip over this part of defining this docstring. So when you put those 3 quotes in there, and what happened was, as I was typing that out, I put 1, I put 2. By the time I hit the 3rd one, it creates a set of 6 quotes for me. And now this is my docstring. It does everything a docstring needs to do. Not a helpful docstring, but it does get the point across. And now everything that's in that tab, so Python is all tab based. Like I don't need to say that I need to end my definition. as soon as I start typing over here, the definition is done. So anything within that tab is all part of this function. So I can call like sin x is, not 6, sin x is np dot sine of x, cos x is np dot cos of x, and then I'll return that sin x and cos x like that. And now I can say x is linspace from 0 to 2 times pi. y1, y2 is sin cos of x. And then I get y1 starts at 0, y2 starts at 1, goes back to 1, and I can plot those results. And it would help if I had plot defined. So let me come back up, make sure. So it is working, but this docstring is not helpful. And the reason that I'm even having you define a docstring is that the most likely person to come back and use your code is you. So if you're using comments and docstrings like this, they're not going to be that helpful. Like you're not going to remember like why did I have something that returns sine and cosine, and like what do I need to import into this? Like what does x need to be? So instead, sin cos of x returns the sine and cosine of the input array x. And I'm gonna get fancy. So I'll put in arguments, array like input for x down x cosine functions, and then output I'm going to do some fancy control click, COS. So that now when I look at my docstring to say, what was this function supposed to be, sin cos? And now I know, okay, it's returning sine and cosine of an array. So specific x has to be an array, and it's the outputs are two array-like functions. So I know that sine of x and cosine of x will both be the same.